Let's revise a little bit on Bohr's atomic model. Electron moves around the nucleus in circular orbit. In order to circulate its orbit, electrons have to possess specific amount of energy. The further the position of the orbit from the nucleus, the higher the amount of energy is needed for the electron to possess. This is because the electron have to overcome the attraction from the nucleus. According to Bohr, the amount of energy needed for the electron to orbit the nucleus can be calculated using this formula, where n is the level where the electron is orbiting and RH is Rydberg constant. For example, let's calculate the amount of energy needed for electron to orbit the first level, or n equals to 1. This level is closest to the nucleus. Since it is the nearest, it will experience the strongest attraction towards the nucleus. Therefore, the amount of energy needed is also lowest. This level is also known as ground state. We can calculate its energy by substituting n in Bohr's formula with 1. The amount of energy calculated is negative 2.18 times 10 to the power of negative 18 joule. Now let's try to do the same to the second level, or at n equals to 2. This level is much further away from the nucleus compared to n equals to 1. Therefore, more energy should be needed to overcome the nucleus attraction. To calculate the energy, replace n with 2 to Bohr's formula. The energy needed for the electron to orbit n equals to 2 is negative 5.45 times 10 to the power of negative 19 joule. Similarly, we can calculate the energy of electron at n equals to 3. Since it is much further away from the nucleus, we can expect more energy is needed. By substituting n equals to 3 in Bohr's formula, we will get the energy needed is negative 2.42 times 10 to the power of negative 19 joule. If we compare the energy needed at level 1, 2 and 3, we can see the patterns where the numbers becomes much smaller as the level increase. But we need to remember, since we are using negative scale, the smaller the number means that it is closer to 0, which means the value is more positive. In Bohr's model, it is assumed that at n equals to infinity, electron is no longer bound to the nucleus attraction. This electron is said to be free electron. The energy of free electron is assigned as 0 because they are too far away from the nucleus. We can also prove this by substituting n equals to infinity to Bohr's formula. As the electron becomes closer to the nucleus, the electron possesses less energy than the free electron. Since the value of energy becomes less than 0, hence the negative value is assigned to the formula of energy.